Acid-Base Extraction Lab Part 2. You will recall that we left the dichloromethane layer drying with the magnesium sulfate in the flask shown. We will need fluted filter paper for our next step, so while that's absorbing the water, we will make fluted filter paper. To do that easily, you're going to fold this circle in quarters, then you open it up, and then you fold the two halves in, and you just basically fold them back and forth just like a fan. Okay, I folded this in so the other one gets folded in, then back, and then finally the last pleat. Okay. This creates a fluted filter paper. You want to pinch the last two flat sides so that they also are pointed. This decreases the contact of the filter paper with the glass, which will slow the filtration down. You can try this at home by getting a big lid, making a circle of paper, and then fold it like I did. Hopefully yours will turn out as well. Take a picture when you're done and include it with your report. The next step is to build the distillation apparatus. Since heat is involved, we want to start with our lab jack elevated so that heat can be removed if necessary. The heat source for the distillation is the thermowell shown on top of the lab jack. This unit is plugged into the regulator device on the lower right side of the hood. The black dial controls the current to the thermowell, which controls the heat. It is important to note that only the top plug is controlled. It is labeled 0 to 120 volts. The bottom plug delivers a full 120 volts. If you were to use the bottom plug, you would likely burn up what was in your flask. For safety, we have put a cover on the bottom outlet, meaning do not use. Collect the pieces of organic glassware to be assembled for the distillation apparatus. Grease the small male part of the joint with silicone grease. When the pieces are put together, rotate the parts to spread the grease evenly in the joint. Attach the rubber hoses to the condenser inlets before assembling the apparatus. The reaction flask is always clamped when using heat. This clamp will support the apparatus when the heat source needs to be removed by lowering the lab jack. Another clamp will support the receiving flask and condenser. You always want to take the time to adjust and position your clamps well. Finally, add blue Keck clips to secure the condenser. A condenser is a piece of glassware that allows gaseous vapors to be condensed to liquid. Looking carefully at the condenser sketch, you will see a central tube inside. This tube is sealed from the outer tube. The function of the outer tube is to cool the inner tube with a jacket of cold water. This will cool the gas and cause it to condense to liquid. This sketch shows how the blue water surrounds the inner tube. The condenser is attached to a water source by one hose, and the other hose goes to a drain. Since you want the water to pool in the condenser, water always goes in on the low side and out on the high side. The objective of our distillation is to remove the dichloromethane from the benzoic acid, which will remain in the flask that is heated. Thus, we need to weigh the flask before filtering the dichloromethane into it. Round bottom flasks roll, so we support them on a cork ring when weighing. We will also add the mass of a boiling chip. This is the dried dichloromethane solution to be filtered. A long stem funnel is used to filter past the connecting tube and into the round bottom flask. Set the heat controller dial at 30 and turn on the power. Eventually, the liquid starts to distill, and you will see liquid dropping into the receiving flask. Check the temperature, as this is the boiling point of the dichloromethane. All of the dichloromethane has been distilled off, leaving the white solid behind. The white solid is now weighed. To verify that the solid is benzoic acid, the melting point is measured.